All right, so you guys wrote down this first part. We are graphing reciprocal functions, which are rational functions. Okay, you guys already wrote down your form. We're just going to talk about what some of those forms mean. Okay, so you have the form f of x equals n over b of x. That's what this textbook uses to show you the value on top is just a real number. The value on the bottom is going to be a function, and it can't be equal to 0. And then this form, where you have the k on the end, that's just going to be a constant term. So when you have a vertical asymptote, that's going to occur where the denominator equals 0, and the domain excludes this value. The horizontal asymptote is at y equals k, so it's equal to what value is added to it, and that's going to be excluded from your range. Okay, so when we find the vertical asymptote, we're going to find the domain with that because the domain excludes that value. And then after we find the horizontal, we can find the range because it excludes that value. Okay, and then the last one here is, it says g of x equals a over x minus h. Okay, x minus h is going to show you where the horizontal translation is. So if you're moving left or right, and then the k is the vertical. So if this is positive, it goes up. If it's negative, it goes down. Now this is the opposite. If you see a minus value here, it's going to go to the right, and if you see a plus, it's going to go to the left. Okay, so this type of graph is called a hyperbola, and the parent function is y equals 1 over x. That is the most basic function. And so when you are plugging these in to find the values, if you plug in 1/2, what's 1 divided by 1/2? 2. 1 divided by itself, 1 over 2. There you go. And then these are the same values but negative. Okay, so that's what's graphed on your hyperbola here. And we're just going to highlight those 2 branches. So each hyperbola has 2 branches. If there's a branch in quadrant 1, there's going to be another branch in Q3. And then if there was a branch in Q2, the other one would be in Q4. Okay, so they're always going to come in pairs like that. And then I asked you to think about what are the asymptotes and the domain and the range. Okay, so we just read that vertical asymptotes occur where the denominator equals 0. So if we're finding the vertical asymptote of this equation, where would the denominator equal 0? Where would the denominator equal 0? Okay, so the value there would be x equals 0. Okay, if you set the denominator equal to 0, that's your vertical asymptote. So yeah, well, you can't have 0 in the denominator, right? That's why this is a vertical asymptote. Okay, because there won't be any points from the graph on it. Okay, and then for the horizontal, we were saying that you have the plus k. Okay, so if you have the plus k on the outside, it's your value of k, but there's nothing added on the outside to this, so it's just going to be y equals 0. Okay, and then this is going to tie into your domain and range. So your domain is going to exclude the vertical asymptote, so x can't be 0. We know that because we've been working with fractions all year, right? So for the fraction, we know that the denominator can't be 0. That's not going to give you a valid answer. Okay, and then for the range, that's going to exclude the horizontal asymptote. All right, and then example 1 just says to find the excluded value of x. So if you find the excluded value of x for each function, you just have to set the denominator equal to 0. And that is going to be your excluded value. Okay, so for part A, we have 5 over x. So that just means x can't be 0. Okay, this is where it's undefined. So the exclusion is going to be wherever that function is undefined, or where you get an error. Okay, so we just find that for part B. All right, so then for this one, x cannot be 2. Okay, so it's just what makes that value undefined, okay? All right, so for example 2, we're going to identify asymptotes, domain, range, and then we're going to graph the function and identify its intercepts. Whenever we are graphing, we want a table, and I'm going to help you with some strategies with the table. Remember, when we say what our asymptotes are, we have to include either x equals or y equals because the asymptotes are lines. Okay, so we have to make sure that we have that. So we're going to do the vertical asymptotes first. In order to find them, you just set the denominator equal to 0 and you solve. So to find the vertical asymptotes, we're going to set the denominator equal to 0 and we're going to solve. Okay, so for the vertical asymptote, we should get x equals -2. The rule for the horizontal in this form is that y is equal to the value of k. Remember that k is always added to the outside. Do we have anything added to this? No. So that means your k value is 0. So if you just plug that in, your y value is equal to 0. So if you don't have anything added, your horizontal asymptote is going to be y equals 0. Now I like to go right from this to the domain and range because the domain is always going to exclude the vertical asymptote. That's what makes the denominator 0. So we have x cannot be -2. And then for your range, it's going to exclude the horizontal asymptote. So that's going to be where y cannot be 0. Now we're going to make tables for the graphs. We're going to make one big table. In order to find some nice values, we're going to remember that the middle of the table is the vertical asymptote there. So the middle of our table is going to be the vertical asymptote, and we're going to do this a little bit differently. So we could see that these had 2 branches, right? So I'm going to split this table, and right where that line is, I'm going to put x equals -2, because that is my vertical asymptote there. All right, and then we are going to graph this. Okay, so if you plug this in, because you have a binomial in the denominator, you have to do 1 divided by x plus 2 in parentheses. If you put it in as a fraction, that's when you get fractions in the table. And so if you want to avoid that, you can just divide by x plus 2, or you can go to your mode, and instead of having your answers as auto, you can change them to decimals. Okay, but if you use the fraction button, that is why you will get answers in fractions. Okay, and then your graph, just like, oh, this one looks nice. Sometimes the graph doesn't show you the full branch here. This one does. So we're going to go to our table set. We're going to start at 0. We're going to go by ones. And what we want to do is we want to have 4 values to the left and 4 values to the right of where our vertical asymptote is. So the vertical asymptote is at x equals -2. So we're going to start by putting that on our graph, as well as the horizontal. Okay, and I usually use a marker for these just so they stand out when I have them on the axis. And then notice it splits it into those 4 quadrants. And so we're going to have 2 branches there. Okay, so when I'm looking at my table, I want to see what's happening on both sides of -2. You should get an error for where the middle of your table is, because that is where the denominator is 0. Okay, so looking at what I have here, I'm going to start at -5, which is -0.3 repeating, or -1/3. And then at -4, we're at -1/2. Okay, at -3, we're at -1. And then leave a space here. Let's graph those points and start to see what this looks like. So you have -1/3, so you're going to estimate about, oops, sorry, I did positive. So you're going to do -1/3, you're going to estimate there. -4, -1/2. -3, -1. So see how this only gives you part of your curve here? Okay, what's going to be really helpful is to see what happens in between -3 and -2. So we're going to want to see what happens at -2.5. One way to do that is you can go to your table set, and where it says table start, if you want, you can just start at -2.5. It will give you -2. And then you can graph that point, and that helps you with your curve so that you can draw the rest of your line there. And then we can put it back to, I'm actually going to start at -2 since that's the middle. Okay, so at -2, again, I'm going to leave some space here because at -1 I'm at 1, at 0 I'm at 1/2 or 0.5, at 1 I'm at 1/3. So -1, 1, 0.5, and then 1/3. So again, it's going to be helpful to see what happens in between these two whole numbers. So I'm going to see what happens at -1.5. Another way you can do that is you can make the change in your table a half, so that when you're here, it's going to give you 2. And that's going to help you graph this part of your curve. Okay, and then the last thing we have to do is identify the intercepts. So if you look at these values, this says y can't be 0. Do you guys know what that means in terms of your intercepts? What intercept always has the y value be 0? The x, right? So this means there's no x-intercept. Okay? So if y can't be 0, there is no x-intercept to be found. The y-intercept, that's actually in our table, because the x-intercept is where, sorry, the y-intercept is where x is 0. So it's 0, 1, 1/2, or 0.5. Okay, so for part B, I want you guys to start by finding the vertical asymptote and the horizontal, just like we did before. And then once you find the vertical and the horizontal, will you find the domain and the range? Okay, so then your vertical, you should just have x equal to 0. Okay, so that was the denominator. So like I said, from there, I do my domain right away. So I know that x can't be 0 here. And for the horizontal, were you guys able to do that one? So what's your k value? 4. So you do have something plus now. So if k is 4, then just your y value is going to be equal to 4. And then from there, we can do our range. Okay, do you guys know what x-intercept? Do you guys, it's not that. Do you guys know what intercept you are not going to have? So if x can't be 0, then there's no y-intercept. Okay, in order to find what the x-intercept is, because you aren't going to see it on your table, to find it algebraically, you can always plug in y equals 0 and solve. Because for every x-intercept, your y value has to be 0. So if we set that equal, in this case your y is g of x. So 0 equals negative 1 over x plus 4. What would you do first to solve? I would do that second. Yeah. You could multiply both sides by x, you just have to make sure that you distribute, which sometimes people forget. And then if you have a negative 4 equal to that, I would probably just divide by negative 1 first. You don't have to. You could also multiply by negative x or divide later. But then how do I get that x out of the denominator? Multiply, yep, times. Okay, so then what would my value of x be? 1/4. So my x-intercept is going to be 1/4, comma 0. You plugged in 0 for y, this was your x. Okay, so now I need to do my table. So when I'm doing my table, halfway in between goes x equals 0. Okay, and I like to look at my table so I can determine what values I want to include. Like I said, just 4 values for each branch would be great. And when you're plugging this into your y equals now, it's going to be plugged in a little differently. We can do negative 1 divided by x. That whole quantity should be in parentheses because the plus 4 is going to be added to the outside. Okay, so you need your parentheses around that, or you can use your fraction button. And then if I go to my table, at 0 I should have an error. And I already kept mine as a half, so I am going to be using the halves just like I did last time. But if you put yours back and you go by ones, that's fine too. You can always go back and forth. I like to put on the asymptote. So if x is equal to 0, you have a vertical. I like when it divides it into the quadrants. So you have x equals 0 and y equals 4. And those are dashed lines. And then we want to see what happens to the left and to the right of x equals 0. Okay, so I notice as I'm getting out here, look how close all of these points are. Because those are all so close, at negative 4, I'm going to do the 4.25. You could do the negative 3. It's easier for me to just graph the 4.25, and then I'll do the negative 2, 4.5, the negative 1, 5, and then I'll find half. Okay, and then here I have the 1, 3, the 2, 3.5. I'll skip the 3 again because the 4 is 3.75. That decimal is just a little bit nicer, so that's why I'm choosing it. You don't have to. You could just do the 1, 2, 3. And then, again, I'm just going to change this to, I'm going to start at 0, and I'm going to make my change in the table by a half. That way I can see at negative half, I'm at 6. At positive half, I'm at 2. And then I told you sometimes your calculator, it stops. The technology isn't there for this, for it to keep going all the way down, but that is going all the way down, and this branch is going all the way up. Okay, so we have to make sure that we're supplementing with what our calculator gives us. So I have 4.25 at negative 4, at 2 and at 4.5, at negative 1 and at 5. And then again, you can see like how small this curve is. So you really do want to have another point that can help you make your curve and then at a half and at 2, at 1 and at 3, at 2 and at 3.5. And so I'm just going to print rate. And then you have your arrow going in both directions there. Okay, so now it's in 2 and 4. And you can kind of look at these and see it looks like a baseball scene, right? Or softball, right? Okay, because they're always going to be opposite from each other. Okay, so you should have those two lines curved. Okay, so we found the asymptotes, the domain, the range, and our intercepts.